Here to discuss the critical intersection of national security and frontier AI research, please welcome Katrina Mulligan, Head of Federal Partnerships at OpenAI, and Patrick Tucker, Science and Technology Editor for Defense One.
Thank you so much for
Thank
being
you.
here. I'm Patrick Tucker. I'm the Science and Technology Editor at Defense One. We're a DC-based national security news site. I cover the effects of emerging technology on national security, and I'm very pleased today to be joined by Katrina Mulligan, who is the lead for government for OpenAI. And who here knows what OpenAI is? Who here has used ChatGPT or a ChatGPT like one of the other OpenAI products? Raise your heads. Don't be shy. It's everybody. Oh, wow, that's very good. Congratulations. Who here has used an OpenAI product or ChatGPT for highly classified information? Or for modeling the interactions of subatomic particles? See, no one. See, you wouldn't think that you can do this. But, in fact, these are already areas that OpenAI is in deep discussions and active partnership with across the US government. And I think it's really fascinating because it points to an alternative direction for the future of AI, slightly different, but complementary to the one that we're all already experiencing through consumer-focused OpenAI and other sort of imitating platforms that we're all using and contributing to every day. So, Katrina, thank you again so much for joining me. Yes, first, talk a little bit about that. You are partnering with a variety of different entities within the government and creating something that is born of the foundation models that we're all enjoying, but slightly different, a kind of an evolution. Describe, if you will, how what you're doing with the Defense Department or with the Department of Energy differs from the OpenAI tools that we all use right now and understand.
Yeah, so I think it's really helpful to kind of zoom out and to remember that this is really the first time in American history that a technology of this consequence is being exclusively developed by the private sector. So if you go back to the advent of electricity or nuclear fusion or many of the internet, those were all moments in technological advancement where the government had a seat at the table. The government was involved in those moments and in shepherding where they went. And that's not true today. And so that's why when the US National Labs reached out to OpenAI just a little bit over a year ago now, we really thought about what a partnership could look like with government that was bigger than just a commercial transactional partnership.
Yeah.
And the problem that the National Labs were trying to solve is that they have highly classified, very sensitive data that is not accredited for the cloud. It can't be put in the typical high-side environments. And so their ability to actually leverage the advantages of frontier AI for those purposes and with that data was really severely limited. And so we made a decision as a company for the first time ever to deploy our model weights directly inside US government-owned infrastructure, which is not something that we had ever done before. And it was a pretty significant decision for us to do it. But there was such a clear and compelling use case at the core, which was really about advancing the future of science and taking the decision cycle time down and really seeing, especially with our new reasoning models, how our models could help really accelerate science, and maybe we could see 30 years of scientific discovery in 10 years as a result of this project. And so we are actually completing the model weight transfer today, which is really, really exciting and a pretty significant and maybe historic milestone.
Okay, before we get to that, tell us a little bit about to help everyone sort of understand what that means. When we're talking about a government customer like a national lab, the data is unique. It's not the open web data that contributes to the foundation model and our interaction with OpenAI, where anyone can go and ask it something and then tailor that interaction based on the contributions of the entire internet. we're talking about a highly specific data set that's very complex. And we're also talking about security concerns that the rest of us don't experience when we interact with these things. So those two things in particular, high security concerns and also highly specialized, specific, and complex data, my understanding of foundation models is that the entire basis of it is it's different from that. It's all of the data, it's all of the compute that you can have, and it's all about harnessing all the stuff that already exists and is just moving like a massive river through the digital ecosystem already. This is, in many ways, kind of it's not a new creation, but it is different. It is sort of a branch that is specific and unique to this group. Like, what are their concerns when you talk to them, and how do those differ from our concerns as a public, or our wants, rather? Because all I want is more like ChatGPT. How do their wants differ from those of all of us in the public?
Well, obviously, security is a really important thing, and also the ability to be confident that the data that they are using with our models, their most sensitive data, is not being used to train future models, which is something that is very easy for us to guarantee, especially because these models are actually deployed inside their infrastructure. They own this; it inherits all of their security. But really, you know, I want to zoom out for folks who really aren't tracking day to day the differences and the progression of the models themselves.
Okay.
So if you look at the original kind of what I call the chat era, we had these models that that you asked it a question and immediately responded to your question, whatever it was. And just like as a human, if I ask you a really hard question and you have to answer me right immediately on the spot, the answer you give is probably going to be decent, but maybe not as good as it could have been if you had taken a few minutes or even an hour to go and think about the answer that you wanted to give. What we did with the new paradigm of reasoning models that really began with our O1 model, and now we have released O3 just a few weeks ago, is we've trained the model how to think before it responds. We've trained the model how to apply frameworks, how to reverse course, how to discover that maybe it's going down a pathway that doesn't work and change to pursue a different and more fruitful pathway. And what the model does as it's thinking is it produces a pretty detailed chain of thought that tells you how it arrived at its conclusions, what information it considered. That wasn't possible in the earlier paradigm, and it actually contributed to what people long thought, that these models were always going to be a black box. We were never going to know, how they arrived at their answers. We were never going to know the information they relied upon, and that was a risk that was unacceptable for certain types of government use. But what the reasoning models have shown is that, like many things that were once true about AI, it's no longer true. And that change really only happened about 6-7 months ago. So this is a relatively new paradigm, and if you're wondering, like, that seems like a big deal, why haven't I heard about it? If you haven't been using these models, pretty frequently, like daily, monthly, you are pretty quickly out of date in terms of what the models can do. And so when we had the reasoning breakthrough that I'm describing, we actually had the national labs. We gave them early access to the reasoning model because we really wanted them. The reasoning models allow you to interrogate data and to explore different types of problem sets that are much more system 2 thinking than system 1 thinking. And that opens up a lot of things that the models can become good at that they previously weren't particularly good at. Yeah. And so we went to the national labs and we said, take this model and throw your hardest reasoning problems at it and see how it does. Like, we weren't sure how it would hold up. They actually did a study that they published. The national labs published it some months ago now. They had 25 scientists from all different scientific domains, microelectronics, therapeutics, physics, you name it, throw their hardest reasoning problems at the model for a week. And they had a lot of conclusions that sort of come out of it, and I recommend the study to you if you are interested. But what struck me was that one of the researchers said that 30 minutes with our reasoning model was worth 3 to 6 months of a human PhD. And when you start quantifying that and when you start scaling what that means, if you've got more than 25 scientists using it, for example, you can really start to see really an enormous potential for acceleration and for impact.
Yeah, absolutely. And so those are talking about the specific, unique needs of government and looking at this. Security, obviously one. The ability to work with these highly specialized, sometimes incredibly large data sets, but not something that's just sitting out there on the open web, something that has to also be secure, but also understood at a tremendous level of detail, and that clarity of process. And I remember 10 years ago writing about little guys that were making neural networks to do like predictive policing, and they'd go to city halls, and the city hall would say, I can't use this because if I use this to justify a decision and I can't explain how this happened, then I'm going to be in legal jeopardy. And so clarity in what was otherwise an opaque system process, there was a DARPA program on it. There was long been this huge ambition, and people never thought that you would get it. Like until not too long ago, DeepMind, Sam used to think that, no, you'll never be able to actually untangle this process. And so now this is that clarity that someone can use to justify a decision that they made if they're a public servant based on the output of a model. That's finally there. So these three things are finally there. And that's contributing to what I've described as an alternative future to AI. Not just the big AI, massive cloud enterprise, huge, constantly flowing set of data created by all users in the world, consumer-focused, open to everybody. There is a new branching small AI that has, as you described it, the capability, the reasoning capability of these larger things, but also dealing with a data set that you can secure as a customer, as a provider of that, and clear to you in terms of the process so you can begin to understand the process itself. It's not just a service that you're consuming, and using infrastructure that you own. And so it could be very large, it could be very small, but you are now in charge in some ways of the different aspects of that. It gives you more control. So this is like the highly customized version of ChatGPT that is now being used by some people in the government, but eventually is potentially open to all of us. And I think that's really important. And so you brought up just a moment ago the effect of this on scientific advancement, and I think it's a really important point, because one of the things that we talk about when we talk about concerns about particularly these very large models is what we now understand is the energy output of them, and the huge enterprise cloud level server farms upon server farms and everything that goes into that. But working with the military, this has long been a concern of theirs, is how to access both cloud, how to make sure that their energy footprint, particularly in some sort of forward deployed situation, if you're at a forward operating base on a hilltop in, Helmand province, you're not going to be able to access, the grid exactly in the same way. So talk a little bit about that, how our understanding of the energy use right now of these large foundation models, in part because of what you've just described, enabling people to bring their own infrastructure to this, but also the rapid advancement of scientific progress kind of changes the discussion about that.
Well, I'm not an energy expert, and so I say everything I'm about to say with a lot of humility, because there may be folks out there who know a lot more about energy than I do. But the rate of one of the things that we are very hopeful about in the partnership with the national labs is that one of the areas that we might see significant advancements is actually on the energy side. I mean, that's certainly consistent with the mission of the labs, and there's a lot of incentive, both commercial and otherwise, to have some breakthroughs in that area. But the other thing that's important to keep in mind is that these models are really giant and they consume a tremendous amount of energy. And then the first thing that frontier AI labs do once they've released them is they make them smaller and they make them more efficient, because there's a ton of incentive to do that. And so, in this new kind of paradigm, I can imagine a world in which there are models that are fine-tuned on government data that are made to be exquisitely good at tasks for which there is no commercial purpose. For example, in our partnership with the national labs, particularly when it comes to helping us understand the risks posed by our models, we want the labs to be able to ask questions of the models about nuclear science, for example, and nuclear capabilities that we certainly wouldn't want available in the public domain or for any user to be able to do. Yeah. And so that's like one example. Another example that comes to mind that I just kind of nerd out about as a former intelligence community person is GeoInt. Our O3 model is wildly good at GeoInt, and if any of you are not planning to see our demo, the demo that we're doing, I think tomorrow afternoon, you should change your plans and go watch it, because I was involved in helping to develop those demos, and they are mind-blowing. Yeah. But the model, the O3 model is already mind-blowingly good at GeoInt analysis, and I think about how incredible it would be if we could actually fine-tune a model on NGA's world-class data set to make it exquisitely good and better than anything that would be available to any adversary. Like, that is the kind of thing that I think could really give unique advantage to the United States.
Yeah.
But I could also imagine capabilities that that the government might want to create that they don't even want the existence of them to be known. And so as we think about where we head from here, I think that we need to start thinking about a different type of public-private partnership, one that builds actually on the really good foundation of the partnership that we have with the U.S. National Labs, and that gives government a seat at the frontier AI table, which they don't currently have.
Yeah. So in terms of what that partnership looks like, to get back to the weights and the transfer, and I thought this was a very interesting thing in a way to kind of really materialize what this means. We all know the OpenAI, we can go to everyone and millions of people all over the world going to it right now on their laptops, on their phones, and interacting with it. But today, this weight transfer actually looks like something. It is a series of hard drives. OpenAI is now not just a service that exists everywhere. It's also, in this new form, a little thing. It's a hard drive that's being transferred today. And because it contains this massive amount of scientific data that can be crunched to reveal new subatomic interactions, you described it as the most valuable hard drive in the world. It's sort of moving from a company.
I think that's right.
Yeah, from a company to the government. I think that's fascinating. And it really sort of brings home that transfer that is now going to be potentially on a different scale available to us all, where something big, ubiquitous, almost vaporous feeling becomes solid, something that we can interact with and control to a much greater degree. So I want to get into what you just brought up earlier, which is the adversary, the importance of geointelligence. GeoInt is geointelligence. I don't know if everyone here is like, because I love it.
Geospatial intelligence.
Yeah. So that is what is happening here, what had happened here, what might happen here, based on what happened here. All of that contributes to GeoInt. It used to be like, there's a Reaper flying over this area. This guy's been here like 5 times, and he really likes explosives. Now
it can also be much simpler than that. It can be, where in the world was this photo taken? If you guys have ever played GeoGuessr, like where we have a picture that we got from the Osama bin Laden raid.
Yeah.
Where was it taken? How could we find this location?
Yeah.
You would be amazed at how good the models are at doing that.
Yeah. No, and I definitely want to check out the demo, because this is how you potentially predict crises before they emerge, especially now, not just seeing them, but also as part of a broader data trend, understanding them in their emerging phases, and that is very essential for deterring conflict. But on conflict, one of the aspects of this particular technology, unlike previous ones, is how democratized it is. And we are, in a certain way, in a competition continuously with both China and Russia to advance capabilities. And the autocratic leaders of those two countries have a very specific agenda that does not favor the interests of the United States people, or democracy in general. So, and yet at the same time, this is information. It is a democratized race. Talk to us a little bit about how you see, from your perspective, both a former within the national security space and now someone that is giving the United States government the most important hard drives in the world, as from a private company perspective. Not you specifically, but people. How do you see this competition right now, particularly within the AI space, and where do you see it going in the next few years?
Well, look, I remember being asked this question a year ago, and I was pretty confident then that we were maybe 6 months to a year ahead of our competitors in this space. And that is no longer true. I would guess that we are at most a couple of months ahead of where China is on this technology. And one of the biggest surprises for us, when we released our first reasoning model in September of last year, I remember going and talking to senior government officials about it, because before we released it, we went and talked to the National Security Advisor, to the Deputy Secretary of Energy at the time, to a number of senior government officials, and sort of said, hey, this is actually like a big change and it's pretty important and you need to be paying attention. And we told them at the time, we assessed that we were about 4 to 6 months ahead of our competitors. It turned out we were 5 months ahead, so that was a pretty good guess. But what we didn't expect is that the first AI lab that caught up with us, that had that figured out how to replicate the reasoning breakthrough that we had, was not a U.S. lab. It was a Chinese lab. It was DeepSeek.
Yeah.
And that was a jarring moment, I think, for us and for our competitors and for the U.S. government. I think it's really important for the United States and for democracies to maintain a lead on this technology. That there is an important, it's not just a symbolic significance, there is strategic advantage to it. And one of the things that I worry about, there was a worldwide poll.
Edelman poll?
The Edelman poll that came out about 8 weeks ago, and it was on trust in AI globally. And what it showed is that trust in AI in the United States and in everywhere else in the Western world is in the low 30s.
Yep.
And trust in AI in China and the rest of the developing world is in the high 70s. So that's not close.
Yep.
It's a really big gap. And what it means is that we could actually win the race to AGI on the technology side, and we could lose it on the adoption side.
Yeah.
Because, what we've done in the United States, I want to stress that we should be concerned about this technology. It is powerful. There are dangers associated with it. I am not advocating that we not focus attention there, and I don't want to be heard as saying that. But I always go back to electricity, and if any of you are students of history, you can come up to me after and tell me the pieces that I got wrong, because I'm sure that I'm going to get little nuances here wrong. But when electricity was being contemplated to be put into homes, it was actually really controversial. There was a whole movement, an anti-electricity movement. People were like, it can kill you, and you are going to put it in homes. And actually, there was the electric chair was one of the propaganda techniques that they used to argue against putting electricity in homes.
Yeah.
They also, there is something about they killed an elephant as part of this. It was really
That was Topsy. That was Edison. Yeah.
But so my point here is that electricity was dangerous. There were home fires. There were actually bad outcomes of putting electricity in homes, but a whole bunch of really good things also happened with electricity. And we did end up figuring out more or less how to harness what was good about it and keep it really safe. There are building codes and ways that we did that. We are going to have to do the same thing with AI.
Yeah.
And so that involves getting out of the defensive crouch. I don't think that the anti-electricity group really stands the test of history. You know what I mean?
Yeah.
I actually think that I have a lot of confidence in our ability to do this safely and responsibly.
Yeah.
But I would say that part of doing it safely and responsibly means we have to partner with government.
Yeah.
I don't actually think that AI labs on their own, left to their own devices with no government involvement, are going to get all the right answers exactly the way we would want them to.
Yeah, and that is part of the reason why you're partnering with government on these very hard data sets, these problem sets, right? I don't imagine that this very difficult work with the Department of Energy brings you more revenue than all of the people all over the world that's using it.
No.
It seems kind of pro bono-y, which is good because that helps to help people within government understand the risk-reward ratio different. If there's one thing the government is good at, it is overweighting risk. Which is good. We want our democratic institutions to do that. They're just not very good at updating that apprehension because of the way mostly the way Congress works, actually. So very good people within regulatory bodies are anxious to move faster. It's just Congress makes a law about oversight and then goes and plays golf for a summer. And if you're in Congress, you know what I mean. They don't even get offended by that anymore. But the importance of changing that risk-to-reward ratio, this is, I think, a thing that a lot of people don't really appreciate or understand. There is sort of a greater risk of not seizing this opportunity than there is from really engaging in it.
We're not good at measuring that risk. And,
Yeah.
and, you know, to your point earlier, I would say, you know, I spent 20 years in government, so I'm like deeply a government national security bureaucrat in my soul.
Yeah.
The thing that I wish that I knew and that I know now and see differently is how difficult of a customer the government is
Yeah.
to work with. You know, it is true. We are absolutely losing money on our deal with the national labs. It is very difficult inside of a company like mine, where every engineering resource that I'm using to do the work that I'm doing with government could be 10 times more lucrative if I applied that resource toward the commercial work that we do.
Yeah.
And so what's happening in the meantime is that a lot of organizations that only exist to serve government are creating a whole cottage industry of stuff they want government to buy that is not being developed by frontier AI labs.
Yeah.
And you know, some of that is going to be good, some of it buyer beware, you know. But what I think is really exciting is that I work for a company that has decided to make investments here, even though commercially it is not,
Yeah.
it doesn't make the most financial sense from a profit and loss perspective.
Yeah.
And now I can only do so much of it. So the way that I'm approaching it is like in the next year, I'm going to do 4 projects. And this year, the current year that we are in, I'm going to do 4 of these projects. One of them is already spoken for because it's the National Labs Partnership. One of them is about to be spoken for. But
I'll break this story out. Just come to defense one. And,
But basically,
let me.
we're going to do one big partnership with the defense industry. We're going to do one with the Department of Defense, hopefully, one big partnership with the intelligence community, and one with the industrial base. And we hope that those projects will be pathfinders to help kind of develop the data that government needs to underpin why we need to make investments in this technology. Because
Yeah.
right now it feels very mushy. It's kind of vibes based, like, oh, everybody needs to get AI because. And what
Yeah.
I want to do, and what the labs are a great pathway to doing, is really cement, like, what is the value proposition and what is government going to get out of it, so that it is easier and more transparent to the Hill,
Yeah.
to leadership inside these departments and agencies, why they should be making big bets here.
Yeah, and to the public, because that's the
And
thing.
to the public.
Because Congress acts as a result of sentiment from the public, and so if we, as a society, continue to exhibit this apprehension about something that is an inevitability, then we relinquish so much of our creative control over it right now, and that would be a tragedy. And so, thank you, because what you're describing, I think, is also really important for helping the public also to build that trust, and especially as some of those control measures continue to roll out to the public. Not that everyone wants to spend a lot of time understanding the weights that they contributed to their own very, unique AI model, but if you have trust that it works, because it's been seen and used and by other bodies that you respect, perhaps other experts, then that goes a long way to creating that sort of trust. And there are other governments that are moving out right now faster on AI that don't have to build those relationships either with the public or with lawmakers. And there's some within our country that have their own sentiments. But this is one of the things that I've always appreciated about OpenAI is its willingness to kind of serve a kind of more public mission, and to be open to criticism and be upfront on different ideas about regulation within a public forum where we all will contribute and add our own senses to it. And that's the dialogue that I think needs to happen. And the ability to understand these things in a way that is unique, specific, that speaks to success experienced by big public institution, but also in a different way by all of us here, is really key to that. So in the last minute that we have, I wonder if you could go just a little bit more into how you see the OpenAI ChatGPT user of the future, just all of us here, benefiting from what you've just described in terms of some of these partnerships, either the rapid advancement of scientific discovery or a new way of understanding AI that is where you can bring your own infrastructure, where you can bring your own security concerns, where you can bring whatever complex data sets you've got, but it's based on that foundation model that you've created. Go ahead.
I mean, look, the kind of partnership that I'm talking about where we're deploying on premises on government infrastructure, that's that's not cheap, and it's not easy, and it's not for every use case, right? Like, that's bespoke, and it's kind of a premium thing. And that's not, I wouldn't, advocate that government over-index on that type of solution for every problem, because there's actually a lot of problems where the off-the-shelf, model that's available in your existing high-side region is totally sufficient. So the key is really understanding which use cases are the big bets that you want to do something bespoke, where you actually need something that is custom built for and fit for purpose, versus when a general purpose model will do. And getting government a little bit more sophisticated about that is important. It's also where I think buyers need to be very shrewd. Like a lot of people are gonna be happy to sell government whatever government wants to buy. And I think, it's important for government to remember there are only 3 companies in this country right now, maybe 4, that are building frontier models. Everybody else is selling something they built on top of those models.
Yeah.
And so understanding that difference, that's not a bad thing, by the way. We want that. There should be a very rich ecosystem building on top of these models and building things custom for government. We certainly aren't going to be in the business of doing every custom thing that government may want, and so that ecosystem is going to be very, very important.
Yeah.
But not all of it will be created equally, and I think buyers need to be paying a lot of attention and doing the best for the taxpayer, because in the end of the day, the thing that I think about when I look into the future is a government that can achieve its missions better and more efficiently and do more for the public that it serves. It's that simple.
Yeah. All right. Ladies and gentlemen, please join me in thanking Katrina Mulligan, Government Lead for OpenAI. And thank you all. I really appreciate it.
Thanks.
Yeah.